Welcome back to our latest deep dive.
Hello, everyone.
Today we're getting into something pretty interesting for anyone engineering with large language models, LLMs. It's called chain of thought prompting.
That's right. We're going to look at how getting these models to, well, break down problems into smaller steps, how that can really boost the accuracy, and maybe just as importantly for engineers, make the outputs easier to understand.
Yeah, understanding the how is key, isn't it? Not just the final answer.
Exactly.
So we'll explore, when you'd actually want to use this step-by-step approach in your projects.
And the knock-on effects, like what does it mean for token usage and the cost?
Right, that classic engineering puzzle, balancing performance, cost, correctness.
Mm-hmm. So the goal today is really practical. We want you to leave with a good sense of how chain of thought works and where it fits into your toolkit when you're working with LLMs.
Okay, sounds good. Let's jump in. What exactly is chain of thought prompting? Lay it out for us.
Okay, so chain of thought, or COTI. Um, it's basically a prompting technique. You're asking the LLM not just for the answer, but to show it's working out first.
Ah, like in math class. Show your steps.
Pretty much. You nudge the model to generate those intermediate reasoning steps before it gives you the final result.
So it's thinking out loud, in a way.
Precisely. And doing that often leads to, well, much more accurate answers, especially for problems that need some logic, some reasoning.
Okay.
And it works even better when you combine it with few-shot prompting. You give examples of how to reason step by step.
Right, showing it the pattern. Okay, that makes sense. But from an engineer's perspective, what are the big wins here? Why bother adding this complexity?
Well, several things. First off, it's actually not that complex to implement.
Oh,
Yeah, the prompting trick. You don't need to fine-tune the model itself. It works with off-the-shelf LLMs.
okay. Low barrier to entry. Nice.
And the second big win is interpretability. Huge for engineers.
Because you see the steps.
Exactly. The model spells out its logic. So if the answer's wrong or just weird, you can follow its reasoning and pinpoint where it went off the rails. That's gold for debugging.
Yeah, I can see that. A wrong answer on its own is just frustrating. Seeing the steps gives you something to work with.
Totally. And there's also some evidence suggesting COTI prompts might be a bit more robust, like they perform more consistently, even when the underlying LLM gets updated.
Oh, that's interesting. More stable results over time.
Potentially, yeah. That kind of predictability is always good news in engineering.
Definitely. Okay, so those are the upsides. What's the catch? There's always a catch, right?
Yeah, usually. The main one here is pretty straightforward. More steps means more text.
More output tokens.
Yep. Those reasoning steps add to the token count in the response. And more tokens generally means, well, higher API costs.
And probably a bit slower to get the response back, too.
That too. Longer generation time. So that's the trade-off.
Cost and latency versus accuracy and interpretability. The classic balancing act.
That's the one.
Okay, let's make this concrete. Can you walk us through an example, maybe one where standard prompting might fail, but COTI gets it right?
Sure thing. Let's take a simple, kind of tricky math problem like when I was 3 years old, my partner was 3 times my age. Now I'm 20 years old. How old is my partner?
Okay, I see the trap.
Right. Give that to an LLM straight up. It might just multiply 20 by 3 and say 60, or maybe get confused and land on 63.
Yeah.
It often struggles with these relative age things.
Yeah, seen that happen.
But now let's try it with COTI. Add something simple like, how old is my partner? Let's think step by step.
Okay, so just adding that phrase changes things.
It cues the model. So it might generate something like this. Okay,
Yay.
step 1. When I was 3, my partner was 3 times 3, which is 9 years old. Rec
Wow.
2, the age difference is 9 minus 3, which equals 6 years. My partner is 6 years older.
Got it.
Step 3, the age difference stays the same. Now I am 20 years old. Step 4, so my partner's current age is my age plus the difference. 20 plus 6 equals 26.
And then maybe a final answer line.
Yeah. Step 5, the partner is 26 years old. Final answer, 26.
Perfect. It navigated the logic correctly because we asked it to lay it out.
Exactly. It avoided the simple multiplication trap by reasoning through the age difference. And, sometimes it might reason slightly differently, maybe calculating the years past instead.
But seeing that process is the valuable part.
That's the interpretability benefit right there.
Okay, so asking for steps helps. You also mentioned combining this with few-shot prompting. How does giving examples boost it?
Right, so few-shot prompting is where you give the model examples of input and output in the prompt itself. Yeah.
Mhm.
When you do few-shot pooping, you're giving it examples that include the reasoning steps. You're showing it the pattern of thinking you want.
Can you sketch out what that prompt might look like?
Sure. Imagine you start with an example like question 1. My brother was 2, I was double his age. Now I'm 40, how old is my brother? Let's think step by step. Answer 1. Okay, when brother was 2, I was 2, 2 equals 4. Age difference is 4, 2, 2 equals 2 years. I'm older. Now I'm 40, so brother is 40, 2 equals 38. Final answer, 38.
So you provide the full reasoning for the first one.
Exactly. Then you add the actual question you want answered. Question 2. When I was 3 years old, my partner was 3 times my age. Now I am 20 years old. How old is my partner? Let's think step by step. And then you just leave it blank for the model to fill in.
I get it. The first example gives it a template for how to structure its thinking for the second problem.
Precisely. It learns the desired format. Break it down, find the difference, apply it, state the answer. This helps guide it, especially for maybe more complex tasks, where just saying think step by step might not be quite enough guidance.
Very useful. So thinking about real-world engineering tasks, where does Qt really shine? When should engineers be thinking, maybe I should try Qt here?
Good question. It's particularly useful in a few areas. Code generation, for instance. You can ask the LLM to first outline the required logic in, like pseudocode or natural language steps, and then write the actual code. Helps ensure the code structure matches the requirement.
Okay, makes sense. Break down the task first.
Yeah. Another good one is synthetic data creation. If you need data that follows certain rules or assumptions.
Like generating product descriptions based on some core specs.
Exactly. You can use CodeOT to guide the model through those assumptions step by step as it generates the description, making sure it stays consistent and logical based on the input seed.
So the general rule of thumb is, if a human would solve this by talking it through step by step,
then CodeOT is probably a good bet for the LLM. If you can explain the steps to solve it, you can probably prompt the model to follow similar steps.
Okay. Now, for people actually implementing this, are there any specific best practices, little tips for writing these Coda prompts effectively?
Yeah, a couple of important ones. Generally, you want the LLM to output its reasoning first, and then state the final answer at the very end.
Why is that order important?
The idea is that the process of generating the reasoning steps actually helps the model refine its thinking and arrive at a more accurate final token prediction for the answer. The reasoning informs the conclusion.
Logical. Build up to the answer.
Right. And also, this relates a bit to other techniques like self-consistency, which we aren't covering deeply today, but having that final answer clearly separate makes it easier to extract just the answer if you need to, say, compare multiple generated reasoning paths.
Got it. And you mentioned something about the temperature setting earlier.
Ah, yes, crucial point. For Qt prompting, especially when you want a single, correct, reasoned answer, you typically want to set the temperature to 0.
0. So no randomness.
Exactly. Temperature 0 forces greedy decoding. The model always picks the single, most likely next word or token. For logical reasoning tasks aiming for one right answer, you want to minimize the chance it goes off on a creative tangent. You want the most probable deterministic path.
Okay, temp 0 for deterministic reasoning with Qt. Makes sense. Now, let's circle back fully to the cost implications. We know it uses more tokens, but let's really spell out what that means for engineers deploying these things.
Right. It's fundamental. Qt means more output text because of those intermediate steps. Plain and simple.
And more text means?
More tokens.
Yeah.
And virtually all the major LLM APIs charge based on token count, both input and output.
Yeah.
So Qt responses will directly lead to higher API bills compared to just getting a short direct answer.
Non-trivial if you're running at scale.
Absolutely. And as we touched on, generating that longer response can also take slightly more time, increasing latency. So it's a resource trade-off.
Yeah.
You spend more compute, potentially wait a fraction longer.
In exchange for getting potentially better accuracy and that valuable window into the model's thinking.
That's the core decision, yes.
So this really crystallizes the main engineering choice here, doesn't it?
Right.
How do you weigh that cost against the correctness benefit? When is Qt worth the extra tokens?
It completely depends on the application. You have to ask, how critical is accuracy here? How valuable is it to understand why the model gave that answer? And realistically, what's our budget?
So for something like, I don't know, generating compliance reports or debugging a really complex system interaction maybe, where getting it right and knowing why it's right is paramount.
Exactly. In those high-stakes situations, the extra cost of Qt might be completely justified. The improved reliability and the audit trail provided by the reasoning steps could easily be worth the price. It builds trust in the system.
But maybe for, say, generating lots of creative marketing snippets or something less mission critical where good enough is okay and volume is high.
Right. In those cases, the cost per query might be the dominant factor. Simpler, cheaper prompts might be the more pragmatic engineering choice, even if they're occasionally less accurate or opaque.
It's all about context and priorities.
Always is in engineering, isn't it? You make informed trade-offs.
Okay, this has been incredibly useful, really getting into the practicalities of CoT. Let's try and wrap this up. What are the main takeaways listeners should remember?
Sure. So, number one, chain of thought prompting makes LLMs better at reasoning by getting them to outline intermediate steps.
Which boosts accuracy and lets you see how they're thinking interpretability.
Exactly. It's great for complex tasks, and even better when combined with few-shot examples showing the reasoning pattern.
But the big caveat,
Mhm.
it uses more tokens.
Right, which means higher costs and potentially a bit more latency. So using CoT is a conscious trade-off, cost versus correctness and clarity.
And practically, if you use it, set temperature to 0 for reasoned answers and make sure the reasoning comes before the final answer in the output.
That sums it up pretty well.
Excellent. So for everyone listening who's building things with LLMs, definitely give chain of thought some consideration. Think about where that extra accuracy and insight could really make a difference in your work.
Yeah, experiment with it. See if it helps solve some of the trickier problems you're facing.
Absolutely. Well, thanks again for joining us for this deep dive. Really appreciate the insights.
My pleasure.
And if you found this helpful, please do subscribe. We'll be back soon with more deep dives into AI tech and engineering strategies. See you next time.